Okay, we are finishing up our little mini 9.1 unit with our radicals, with simplifying those expressions with conjugates. And conjugates, they're kind of new, but you also kind of know what they are, okay? So let's backtrack a little bit and let's talk about something real quick. You can write this along with me or you can just listen. But I know that what I need to do anytime I have a fraction is to make sure there is no radical in the denominator. And what we've been doing is just saying, okay, well, all I need to do is multiply that by that same radical, right? And that's going to get rid of that. Well, not in this case, because we know that we have to distribute this square root of 3 to both the 2 and the square root of 3. So what we get is 2 times the square root of 3 plus 3. So we solved our problem on one side, but now we have a problem again. So if we go back and we say, well, I'll just multiply it by the square root of 3, then we'll solve the problem on this side and we'll end up with a 3 times the square root of 3. So it just kind of goes back and forth, back and forth, back and forth. That is not going to solve our problem, but there is a way to solve that problem. What we will do is multiply by the conjugate. Again, that sounds like something new, but it's really something we've been talking about for a while, and that is our difference of squares, right? So we have a plus b times a minus b, and what I get is a squared minus b squared. That's 2 squares and a difference, right? What these two right here together as a pair are called are conjugates. That is a U, sorry, it's right there. Conjugates, okay? What that means is if we have an a plus b, we need an a minus b, and that's going to cancel out our middle term. If we have an a minus b, we need to get an a plus b. So let's just kind of review why that works, okay? So if I am taking the square root of 7 times the square root of 3, I'm sorry, let's start back. The square root of 7 minus the square root of 3 times the square root of 7 plus the square root of 3. Well, if we FOIL that, or distribute, right, we know that this has to go to both of these. This has to go to both of these. The first thing I get is a 7 times the square root of 7 times 7, which is the square root of 49. Then I get a minus a 3 times 7, which is the square root of 21. Which this is a perfect square, but this is not. So this is not looking good already. And now I'm going to have a positive 3 times the 7. So now I have a positive, and I have a negative square root of 3 times square root of 3, which will give me the square root of 9. When I combine like terms, because remember I can combine these, and because I have one positive, one negative, those will cancel out. This is a perfect square. That is a 7. This is a perfect square. That is a 3. And our answer is 4. So we have gotten a whole number based on just these radicals, okay? There is a shortcut. I know that if I take the square of the first term and the square of the last term and get the difference, those middle terms cancel out, and that's all I have to do. So when I am multiplying these conjugates, right, I have a conjugate. I have a square root of 10 minus 6. The conjugate of that is the square root of 10 plus 6. So what I'm going to do is I'm going to take that square root of 10 and I'm going to square it. And I'm going to subtract the square root of 6 squared, which, as we know, when we the square root sign and the square cancel out, we get a 10. Square root sign and the square cancel out, we get a 6, and our answer is 4. Just so happens it's the same thing. So there's kind of an explanation there in the middle, but let's jump right in and take a look at what we've got here, okay? So looking at number 3, we have 1 over 5 minus the square root of 2. When we're getting that conjugate, remember we have a difference here, so we need a sum. So we are going to multiply that times 5 plus the square root of 2. And what we do to the denominator, we must do to the numerator. And of course, when we're multiplying fractions, we just go across. That gives us 5 plus the square root of 2 over 25 minus 2. What I've done is I've taken that first term and squared it, minus that second term and squared it. I can solve that numerator, or that denominator, sorry, I can't solve the numerator. It's going to stay 5 plus the square root of 2 over 23, and we have rationalized our denominator. Let's do that again with number 3. My denominator is a difference, so my conjugate must be a sum. So I will just take 4 plus the square root of 5, and I've got to do the same thing to the top. And what I'm going to do here is this 3 is going to distribute to both of those, right? So our numerator becomes 12 plus 3 times the square root of 5 over, square that first term, 16, minus, square that second term, that's 5. Now I can simplify my denominator, and I get 12 plus 3 times the square root of 5 over 11. So far, so good, I hope. Move on to number 6. Now I have a square root in the numerator and a square root in the denominator, and it's perfectly fine that we have that square root up top. We want to get rid of the one in the denominator. I, again, have a difference in my denominator, so I want to take my conjugate, which will be a sum of those same two numbers. And we're going to do the same thing with the numerator. Again, this is going to distribute to both parts. And we're going to get 4 times the square root of 6 plus the square root of 3 times 6, which we can solve that and get the square root of 18 there, right? But let's go with the bottom real quick. We're going to square that first term minus 3. Now we've got some cleaning up to do. So I've got a 4 times the square root of 6. I can't do anything with that quite yet, but what I can do is make that an 18, right? Because 3 times 6 is 18. And then 16 minus 3 is 13. Well, I know we're not quite done because this is not in its most simplified form. So I'm going to keep on going. I have 4 times the square root of 6 plus the square root of 9 times the square root of 2 over 13. That will simplify to 4 times the square root of 6 plus 3 times the square root of 2 over 13. We cannot do anything with these because these radicals are different. That is our simplified answer. Go ahead and do number 6. Come back and check your answer. All right, so the first thing, we actually have 2 square roots here. So that's really not going to be any different than what we've been doing. We're going to take the conjugate of that. And because it's a difference, we're going to take the sum. And we're going to do the same thing to the top. And again, this is going to distribute to both of those, okay? So we get 2 times 4 times the square root of 3 times the square root of 3, right? Plus 2 times the square root of 3 times 5 over this term squared. So when we have, let's just put it right here, when we have 4 times the square root of 3 squared, remember that's going to distribute to both. So that's going to give me 16 times 3 minus 5. So let's clean that up. 2 times 4 gives us 8 times 3 right there, then 2 times 15, and 16 times 3 is 48 minus 5. We have a little bit more to clean up. We have 8 times 3 is 24 plus 2 times the square root of 15 over 43. I can't do anything with this 15. And that is as simplified as we get. That one is a little bit more difficult. We can go over that one in class tomorrow if you guys would like. That has a lot of distributing. Taking a look at the next page. Let's skip over to number 8. Lots and lots of square roots there, right? So what we're going to do is, first thing first, multiply by that conjugate, right? Now we have a sum of conjugates, or a sum of square roots. So to take the conjugate, we just have to take the difference. Same thing, or same terms, I should say. Same thing on the numerator, and let's go. This 5 is going to distribute. We have the square root of 5 times 3 minus the square root of 5 times 5. Then we have 3 squared, that gives me 3, plus 5, minus 5 squared, that gives me 5. Simplify 15 and 25 over negative 2. That's going to simplify minus 5. And I'm going to put my negative right out front. And there we go. So when you have 2 square roots, you're just going to take the conjugate, and as you can see, they're still going to simplify out. All right, let's do number 9. This one is a little bit more intense, so here we go. All right, so the first thing we need to do is take the conjugate. Now you can see you've got a negative out front. That stays negative, but we're going to make it a positive 3 times the square root of 3. Okay, so we have a negative 3 plus 3 square root of 3. Same thing for our numerator. And we multiply this here. We have a negative 15 plus a 15 times the square root of 3 for our numerator. And we have, so negative 3 squared gives us 9. And then remember, when we have this negative 3 times the square root of 3 squared, we square both of those terms. So that will give us a 9 times 3. And when we combine our like terms, we get 9 minus 27. And we still have a negative 15 plus 15 times the square root of 3 over negative 18. Now, it looks like we are done. And I said there was a little bit more going on in this one, and that is because we need to simplify some more. We're not simplifying our radicals, but we're simplifying our coefficients, okay? We can take a negative 3 out of all of these, right? If I take a negative 3 out of this top part here, I get a 5 minus 5 times the square root of 3. And if I take a negative 3 out of 18, I get a negative 3 times 6. Now I have some multiplication, and I know that these negative 3's can cancel. And what I'm left with is my simplified form. Number 10, again, looks a lot like, it's going to look a lot like number 9, I should say. We have a sum, so for our conjugate, we need to find the difference. I'm going to multiply the top. That gives me a 12 minus a 12 times the square root of 5. Then I'm going to square my first term minus the square of my second term. And I can't do anything up here, but I can finish out this right here. That's going to give me 12 minus 12 times the square root of 5 over 16 minus 80, and that simplifies to 12 minus 12 times the square root of 5 over negative 64. I can take a 4 out of all of those, right? I can actually pull a negative 4 out of all of those so that I don't have that negative in my denominator anymore. So when I pull a negative 4 out of my top, I get a negative 3 plus a 3 times the square root of 5. And I get negative 4 times 16. Those negative 4's cancel out, and I am left with negative 3 plus 3 times the square root of 5 over 16. Excuse me. So number 11, we're not taking the conjugate or anything. We're really just kind of talking about reviewing that cube root. So we have a little 3 as our index. That means these are cube roots, right? And all we're reviewing is that these will distribute to both. So we have the cube root of 2 times 108 gives us 216. And the cube root of 2 times the cube root of 135 gives me the cube root of 270. So if I plug in my cube roots, let's see if I can get that to work with that light, sort of. Oh yeah, I forgot about that x, y'all. You don't even know how excited I am that y'all taught me about that x. All right, so look at that, 216 right there on my list. So the cube root of 216 is 6. So I don't have to do anything with that quite yet. I'm going to check this. It's 270 on my list. No, it is not. But look what is on my list, 27. And I know because of my product property, and the cube root of 27 is 3. So what happens here is this is 6 minus 3 times the cube root of 10. That got a little squished. I apologize. Y'all go ahead and try number 7 and number 12. Make sure that those answers, you either check those with the key. Make sure you know how to do those, okay? So let's look at number 13 and we will be done. So what the quiz is going to ask you to, first things first, is tell you to round your answer, not round your answer. It's going to tell you to leave it in simplified radical form. All right, so that's what we're going to do with that first. So we're looking at a ratio. The ratio of the length to the width of a golden rectangle is 1 plus the square root of 5 to 2. So when we're setting up a ratio, it might say, this might have this colon here, it might say 2, it might say 1 plus the square root of 5 over 2, right? So if we're looking for the length and we set up this ratio, well, our length, so it says length to width, this is length and this is width. Now I'm given that my length is 62. So because I put my length on top, I'm going to put 62 on top. And I want to find my width. And I'm just going to cross multiply here, and I'm going to set that up, which will give me W times 1 plus the square root of 5 equals 62 times 2 is 124. I want to get that W by itself, so 1 plus the square root of 5 and 1 plus the square root of 5. So now what I have is W equals 124 over 1 plus the square root of 5, and we just spent 20 minutes talking about how we cannot leave that in the denominator, but we know how to fix it. So all we do is take that 124 over 1 plus the square root of 5 and multiply it by its conjugate. Right now we have a sum, so our conjugate will be a difference. 124 times 1 is 124. 124 times the square root of 5 is just what I just said. Then 1 squared is 1. Root of 5 squared is 5, which gives us 124 minus 124 times the square root of 5 over 4. I bet we can simplify, right? Oh, I'm sorry, negative 4. Put a little arrow up here. I'm going to pull out that negative 4. I'm going to pull that out of that 124. So when I pull a negative 4 out of 124, I get a negative 31 plus 31 times the square root of 5. And of course, I've got a negative 4 down here already. Those can cancel out. My answer becomes negative 31 plus 31 times the square root of 5.